All right, I'm gonna make this quick correction here. So the first question is asking, the idea is that Mr. D has to go from home to Canadian Tire to Sizzler. Okay, and so there are four ways to go from here to there, and 3 ways to go from Canadian Tire to Sizzler. And in this case, we want to know how many ways can Mr. D travel if he's going from home to Sizzler and then back home, right? So the idea is you have 4 times 3, right? 4 times 3 ways. But then because you've already on your way there used up one of the 3 options on the way back, you only have 2 to get back to Canadian Tire and only 3 to get back home. So 72 distinct routes that one can take in that case. You're making a password, it's supposed to be 5 characters long. Okay, 5 characters long. And there's uppercase, lowercase, we've got 26 and 26 digits can be used. So that's 10 and 4 special characters as listed there. How many different passwords are possible? Assume that repetition is allowed. So I just add everything up and I have 66 options per slot, right? Because it's just saying 5 characters long. So we're not saying it has to be letters first or numbers second and whatnot. We don't care. So it's 66 options to the power of 5. That's your answer. Because repetition is allowed, so the number doesn't drop. For B, how many of these do not have any repeating letters? So if repetition was not allowed, how would that change? So basically it would drop, so you can use permutation. So that's an alternate way of solving, and that's your answer there. If you want to start with a Z or a hashtag, right, you've got those 2 cases, and I split them up even though it's done the same way, right? So no repetition is allowed. So if Z is taken, then you're down to 65, 64, and so forth. If you consider H, right, that OR case, there's only 1 to start, and then 65 all the way to 62. So it really comes down to 65, pick 4 for both cases. You get the same answer. You just add them up, and there you have it. How many passwords can she create that have repeating characters? Meaning, in this case, at least 1 repeated or more, right? That's the implication here. And so basically what this is asking you to do is take your total, all possible, with repetition, take away the passwords that do not have repetition. Okay, so my answers from A and B, subtract them, and you end up with that many passwords there. The last one was just a outcome table or a tree, whatever you wanted. What I did want to see is the outcomes listed, right? So in both of these cases, you end up with the outcomes listed. So if there's just 2 events, then outcome table is probably the way to go. If there's more than 2, you can't use an outcome table. So this page is solved as follows. Next, you've got the cars. You've got 5 Civics, 2 Odysseys, 3 CRVs, and 2 Accords. So there's 12 cars in total. And no 2 have the same color. So that's basically saying they're all unique. Okay, they're all unique. So the dealership wants to display them. It's almost like lining up for a picture, right? In a row, how many ways can they be arranged? And it's either 12 pick 12 or 12 factorial, or if you want to use the fundamental counting principle, whatever the case may be, that's the answer you get. How many different ways could the cars be displayed? If the 5 Civics must stay together. So there you have your 5 factorial for them being together, and you count, right? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, counting that big one as 1 slot. So it's 5 factorial, 8 factorial. That's how you get that. If all makes and models must stay together, so you've got your Civics, your Odysseys, your CRVs, Accords, right? So those are like the 4 groups that you make. And technically, if you zoom out, there's just 4 slots that you can move. Right? So that's where the 4 factorial, that's the zooming out part. You could have used slots, it's probably a better idea, but you get 69,120. How many different ways could the accords be displayed? If the accords have to be on either end of the line. So you can have either, the reason you start with 2 and then 1 here is because you're kind of looking at 2 different cases, right? You have the case where the one accord is here and the other accord is there, or you flip them. So that's why you go 2 times 1. That's the 2 factorial here, and the 10 factorial is because everything in between can go every which way. It's not fixed. How many different ways can the cars be arranged if the Civics are not all parked together? So we already did the work where Civics must be together in B. So my idea was go A minus B again, right? A minus B, you end up with all the ways where they are not all together. Some of them might be together, but we're taking away the ones where they're all together, they're all side by side. Here you have your bonus. So again, I started this up for you already. I used the formula. I'm going to take my time for this one, right? Knowing that NPR calls for n factorial, so whatever this number is, factorial, then whatever this number is minus the number that's on the other side, or the expression, r factorial, right? So this is what guided me in setting up this expression here. So I have n, right? N factorial, then it's n minus 2, right? N minus r, in a sense, factorial, and you have that. You notice at the top, you have n has to be greater than or equal to 0. The bottom, n has to be greater than or equal to 2. You break down the top, because that's the larger one. You cancel that out. You end up with n times n minus 1 is equal to 42. Cleaning that up leaves you with this. I actually distribute it, right, to get that is equal to 42. Bring the 42 over, subtracting. And again, here's the trick that I'm going to show you one more time. I'll use this space right here. So when you're factoring, okay, you're basically rewriting this in terms of the 2 binomials that created it. So you want the variable, of course. And what I do is, when the cases we're going to deal with is the first sign goes here, and then the product of the 2 signs goes here. This is negative times negative, gives you a positive. Okay, so in this case, you know that one number is going to have to be negative, one number is going to have to be positive. And then think about it. What 2 numbers multiply to negative 42? 6 and 7. That is just coincidence, by the way. 6, 7. So let's say you tried, I'm going to just go light here, 6 and 7 like that. If you FOIL this out, you would for sure get in here, the first smiley face, you would get negative 6n. The second smiley face, like if you multiply the n's, you would get plus 7n. Okay. Now check, if you add this up, you end up with positive 1n, which is not the case. You need to have a negative 1n basically. So what I'm going to do is I'm going to switch these, because I know that there's a difference of 1 to be had there. So I'm going to go 7 and 6. So if I multiply the inside, I get negative 7. If I multiply the outside, I get plus 6. When I add them up, I get negative 1n, which is exactly what I want, right? I want negative n. So you know you did this right. So what you need to remember is, basically, now we're going to ask ourselves, what do I need to make this 0, the first bracket? Because if I make the first bracket 0, it's going to turn everything on this side 0 and matching the right-hand side. So in this case, n is equaling to 7, so it's the opposite of the sign you have in here. N is equal to 7 will turn this thing into 0. That's one solution. On the other hand, In this case, n would have to be -6, so opposite sign of whatever is in the brackets. That one doesn't work. Why not? Because n has to be greater than or equal to 0, or n has to be greater than or equal to 2. Otherwise, it doesn't work. So this is the answer. What you can do is to check. Plug this into this. 7 factorial over 7 minus 2 factorial. That is a 7 factorial over 5 factorial. Clean this up. 7, 6, 5 factorial over 5 factorial. Cancel that out. 7 times 6 is 42. Okay? So you notice that, oh, left side, this side, matches that number. So we're good to go. That's your check. Okay, keep going. How many odysseys, how many ways can the letters in the word odysseys be changed or are rearranged? So 9 letters, there's 3 S's, 2 D's, 2 E's. So you go 9 factorial, and then the 3 S's, the 2 D's, the 2 E's to get that. What if it must start with an S? I go tricky because S is one of the repeats. So you consider all 3 S's. So technically we would want to branch off into 3 cases because there are 3 options. However, because they're all the same, I'm not going to bother. I'm just going to say, you know what? We're just talking about the same case. It doesn't matter which S I put up front. We're not going to consider every case because they're all the same. They look exactly the same. So 1, okay, that's there. And then the remaining 8 get scrambled on the side here. And at the bottom, you only go 2 factorial for the S's because there used to be 3, but 1 is now fixed and only the other 2 are being moved around here. So that's why this first number changes to a 2 from the previous line here. Okay, so you just have 2, 2, 2, and at the top you have 1 times 8 factorial, and that's how you get your answer there. Keep going. Hands of cards. Okay, so you're grabbing 6 cards at a time. Order doesn't matter. So we go 52, choose 6. There you go. That's how many hands. How many hands would have exactly 3 hearts? So remember, if we want 3 hearts, the opposite of it would be anything that isn't a heart, but you still need 6. So from the 13 hearts, I'm going to choose 3. And how many cards are left that are non-heart cards? Well, we're going to go 52 minus the 13 hearts. So there's 39 cards that are something other than hearts. So from the 39, I'm going to choose my remaining 3 that I need to get the 6, the hand of 6. So multiply the answers, you get that. Remember, when it's a word problem that you're solving, and if I'm not asking you to do this by hand or evaluate, do not use the formulas for combinations. Just type that into your calculator and get the numbers accordingly. Next. Determine how many hands would have at least 1 face card. At least 1 face card. So 1, 2, 3, 4, 5, right? And all the way to 6 actually. So the reasoning I wanted you to utilize here is, let's consider all hands. This was done in A. Let's take away the hands that would have no face cards. So 12, choose 0. From the 12 face cards, I choose none. And how many are left? How many are cards that are non-face, right? 40. 40, choose 6. And remember, this adds up to 52, and this adds up to 6, so we're doing good. So I'm going to subtract all the hands that do not have any faces in it. So I go total minus no faces. These cards, these hands have at least 1 face card in them. Okay? Here's your pathways. Again, I used the counting method and I used the formula. I made a mistake here, so be careful. And that's where doing the counting method is a good idea, because you can check whether or not you're doing it right. Making teams of 5, So we've got 4 grade 11s, so this is kind of tricky, right? 4 grade 11s and 8 grade 12s. So there's 12 people in total. So from 12 we choose 5, right? Teams of 5, boom, you get the 792. How many teams can be formed if they need to be exactly 3 grade 12 students on the team? So from the 8 we choose 3. And remember, it's almost like how many are non-grade 12 students? Well, it's the 4 that remain. So you almost go 12 minus 8 to get the 4. It's kind of like the same idea as our cards. And then the 3 and the 2 add up to 5, so there we go. So you come up with the numbers, you get that answer, it's 336. Back side. A team of 5 has been selected. The coach and the assistant would like to take a team picture. How many ways could the team pose, right? We're posing, we're arranging, order matters, whether a player's all the way on the left or second one from the left. It does matter here. It is a different permutation. We would count it as a different picture. And it's just 7 factorial or 7 pick 7 because there's a team of 5 and then there's the coach and the assistant. So they're not the team, right? The team is the 5 and then so there's 7 people involved here. How many ways can the team pose? The coaches have to be on either end. So, right, you've got 2 different scenarios, right, where you have coach and assistant or assistant and coach. That's why you start with a 2. So it's 2 factorial and then 5 players in the middle, 5 factorial ways, so and multiply. We've got green marbles, they're identical. So I go 15 in total, but I divide 5 factorial, 6 factorial, 4 factorial because they're exactly the same. You get a really big number at the top, but if you divide, you do get the right answer. What if all green marbles are together? There's 4 green marbles, right? So 4 factorial, you zoom out. I made 15 slots here, so I counted when this was removed, and you count that as 1, then there's 12 slots if you zoom out. And you still have to divide out the repeats. And it cancels out nicely. And I end up with this at the top, this at the denominator. If you divide them, you get that. How many ways if all colors are together? Well, think about it. All of them are grouped, right? So 5 red, 6 blue, 4 green. And remember, there's 3. If you zoom out, there's 3 big slots that you're moving around. So this is zooming out. You divide by the repeats, cancels all out. So you're really just left with 3 factorial ways, which is 6. You're displaying out of 24, you have to display 6 at a time. That'd be 24 pick 6. I give myself a check mark there. A 105 factorial over 102 factorial. You cannot do this on your calculator, so you break down the top until you see that it matches, you cancel that out, you end up with that. 10C4, I used the formula. Okay, if you're wondering how did I get that, I used the fact that NCR is n factorial over r factorial times n minus r factorial. Okay, and so I'm basically plugging in and going. And so I break down the 10 till I get to 6 factorial, I cancel that out. I break down the 4 into 4, 3, 2, 1 just to get rid of all factorials, and you get your answer there. And that's it. Hope that helped.